Okay, is anybody aware of the fact as consumers, you're probably not big shoppers just yet, but did you know that when you order in bulk, companies will charge you less per item? Did you know that? Any of y'all shop at Costco or Sam's Club? The reason you go there is because when you buy a whole bunch, you save a little money per each. So they give you a deal the more you buy. And that's what we're looking at. If you buy between 0 and 24 shirts, you have to pay $17 per shirt. So for like a school like this, let's say the cross country team wants to buy shirts, there's 20 of them, they pay $17 per shirt. But then if they pair up with other teams and they want to order 40 shirts, then it's only $15 per shirt. And then if they pair up with a lot of teams and they need over 50 shirts, it's only $14 per shirt. So you get a deal the more you order. That's what we're looking at. So in order to write a piecewise function, I'm going to just break down each part of this. This part, $17 per shirt, to write down equation is 17x plus 20. And the 20 is the processing fee. That's the one a lot of people would miss. And I almost feel bad about it because it's just kind of like hidden on this. But I mean, that's kind of real life on websites. Like they put it tiny, like, oh, plus taxes and all that stuff, right? Oh, a hidden processing fee. Why am I surprised? Okay, 1580x plus 20 for that middle scenario, and 14x plus 20 for the last scenario. Any questions? All right, so now we have to get into making this a little bit nicer, making it fancier, like a real piecewise function. So the only thing I'm going to do there is I'm going to write f of x equals, and then I'm going to do a fancy bracket to include them all, just like we've seen this. So that's like, it's a parenthesis, a point, and a parenthesis. And now that we have f of x equals in the fancy brackets, we can erase our y equals on each of these. I wish it was all a little bit closer. Let me try again. All right, it's looking fancier and fancier, more and more official, more and more like one function. It's all t-shirts after all. So now we need to somehow indicate using our math symbols these ranges. So we only get this price if we order between 0 and 24 shirts. So I'm going to say this is for more than 0, less than or equal to 24. And then X represents t-shirts. And this one's for between 25 and 49. You could put 24 here and not do the sign here. But we're talking about t-shirts. There's not a half a t-shirt sold, so we can jump to 25. And then the last one is for over 50 shirts, include 50. Oh, I gotta write the word if. Oh. Here we go. Do you think there's a comma? There is a comma. Yeah. Let's put a little comma in there too. Alright, who's got a question? We're not done yet. We're gonna read our problem closely. The last sentence is determine the total cost of ordering 26 shirts. So I have to figure out. I'm on the website trying to order shirts. I have to figure out. Okay, I was only gonna do 24, but I saw the deal, so I convinced my parents to buy one too. I'm up to 26, so now I'm at this price. So for 26, we're in between the 25 and 49 range. We'll only plug it in to the middle equation to find the total cost. Alright, I'm just seeing a few calculators out there. If you don't want to pull a calculator out, go ahead and have fun with doing 15.8 times 26 plus 20. Have fun with your math. Why are we? Why are we doing it? Maybe read it, look at it, lock in a little bit. You get a calculator out? Who's got calculators? Can I use this? No, you're really. You're about to cross the line. Cross the line? I don't have a calculator. Here's a secret. The media center has some that you can check out. If you're ready, you can keep it all here and bring it back and top secret. Can I go right now? No. Just go on your own time. And they might say like, oh, this is for the Ace Math students, and you say, well, I'm gonna this is all experience math, and she'll say, okay. Or she might say, come back next week. But they're there. Thank you. Yeah. So who's got the answer? John? $400 for t-shirts? It's 480. 430.8. Let's answer in a nice complete sentence. So, the truth is, when you go to a t-shirt store, or even if you're working on a website ordering shirts, there is no human right there looking at how many you ordered and then typing in or punching into their inventory computer how much they're going to charge you and calculating it themselves and putting it out. There might be some really small independent stores that are still doing that. But the truth is, the software is doing this. When you go on the website, if you click in there that you want 60 shirts, the website automatically grabs this equation. Or if you're at the store and the cashier or the store clerk types in 10 shirts, the register or the computer automatically pulls this equation. How does the computer do that? How does the computer know the piecewise function? We don't have to do it by hand. Does the computer know it? How? Yeah, but what? By magic? Did God speak to it? How's it doing it? How's the computer doing that? What technology? It's programmed. Who programmed the computer? A human programmer types the code into that software for that company. Okay. So while the store clerk doesn't have to understand the piecewise function, the human that wrote the code and got the computer to understand it very much does understand piecewise functions. And this is what's going on in the background of all of our computers, of all of our websites. The code in there written in a computer language by a person tells the computer which function it should be applying the numbers into, and then the computer calculates it. But it's not by magic. It's by a human being sitting in Algebra 2 class, just like you are, figuring this out, going into AP Computer Science and learning a programming language, and then creating the program. Okay, so this is real. This is real math used in all of our really all of our purchases come through something just like this. So when you look at yesterday's assignment, you might feel like this looks like a bunch of mumbo jumbo and nonsense, right? But then when you look at a t-shirt problem like that, you say, oh right, this understanding really is applied in all of our marketing, all of our businesses. So let's look at our graphs from yesterday that look like nonsense but really can be applied in certain ways. Did I do number 8 in 4th period yesterday? Okay, and number 7 you already checked. So what I do when I look at your graphs, the quick way for you to know you've done it right, or for me to do it right, is just by checking the slopes. So it's a flat slope, and then it's a positive slope, and then it's a negative slope. And when I look at this one, I should see up, down, flat. So when you look in the middle here, if it's flipped, you got your slope wrong. I also can look at the open and closed dots. So you probably have more questions on the second page. So any questions on this one? Figuring out your slopes and all that? Should we go to the next page or the other? Oh, no, not really. Ready? Colin, how'd you do? Are you ready for the next page? How'd you do on that? 11 through 14. Yeah. Did you write your if statement? Yeah. Okay. There you have it. According to Colin, it's pretty easy. All right, I'm gonna do. Did I do any of these yesterday with you guys? I did 12. I'm gonna do 14 right now. Let's try it again. This is the third concept in piecewise functions. First we plugged in, then we graphed, we just looked at a word problem, and now we're seeing this and we have to figure out how to write the equations. Each little skill that you practice helps you understand the concept as a whole. So the first thing I have to do is figure out the slope. Shoot. I need a bigger area. Come on, programmer, make this better. So I'm going to write y equals, and I'm hoping to do mx plus b, so I need to know a slope. So I'll take a look at, I read it from left to right. So I'll look at this left side first. Looks like it's going up 2 over 1, up 2 over 1. So I would expect a good amount of people to be able to figure out the up 2 over 1 part. But where I'm going to lose, probably a majority of people, is what is the b value? And y equals mx plus b. How do we figure out that b value? The graph is broken right here. It breaks and it switches. So I can't really see. This isn't the right y-intercept. I need to know the y-intercept for this one. So I'm going to continue drawing the line. Up 2 over 1. Up 2 over 1. Up 2 over 1. And when I continue drawing the line, I can see that the y-intercept, the b value, would be positive 2 if this line extended. So the first equation is 2x plus 2. And the second one's a little bit easier because you can see the b value. This is up 1 over 2. And the y-intercept is a negative 1. How to go following and go to right? Are you willing to share a mistake? Oh, you do? Well, I'm not done yet. I'm going to make it look more complicated. Yeah, let's hear it. How would you separate up 1 over 2 from like a slope of 1? A slope of 1? A slope of 1? I hope I didn't cut you off. Up 1 over 1 would look like this. Be like, Well, up 1/2 over 1 is the same as up 1 over 2. So did you write 1/2 over 1? Oh, that'd be pretty clever. It's the same thing. Up 1/2 over 1/2 is 1. All right, my if statement. If, I need a comma here too. I've been neglecting this comma. Let's talk about a comma. All right, my if statement has to do with where the hinge is, where the break is. And that break is at -2, where x equals -2. So I'll say this one was on the left side of -2, so I say x is less than, and the other one is on the right side of -2, so I say more than. And here's your fancy full-out piecewise function from number 14. What about you, Jacob? Did you find any success in writing lines from here? Did you find any slopes? Yeah, you can even try 15 right now if you feel like you're understanding it, and check 15 in the back of the book. Especially if you just, you weren't totally sure yesterday. Test yourself right now. I guess so. All right, I guess we got this one down. Right, here's the other answers for 11, 12, and 13. You guys maybe just copied the answers, so take some time and try to understand it. Yeah. Less than or equal to. All right, well, today you get your quizzes back. So, as you're working on this right now, or maybe you're working on your new assignment, I'm going to be passing your quizzes back. But I am going to be a little bit generous with corrections. And in order to encourage you to correct it, I'm going to be giving you some points back, okay? Which you don't generally do, but there were so many quizzes where there was good work done that showed progress, but it just wasn't enough to give points to them. I thought you deserved a second chance to figure it out. So we're going to do some corrections. In focus, if your quiz is corrected, the score will be a -1 for each wrong answer. Okay? So it's worth 36 points. So right now, when you look at your score, each wrong answer is -3. Okay? As long as you correct it, each wrong answer will only be -1. So I'm pretty much giving you 2 points back right now for correcting. Okay? So if you do, let's say hypothetically you got every single one wrong, which nobody did. But if a person came in with every single one wrong and they did all of their corrections right now, the lowest possible score is 26 out of 39. Okay? Just for being here doing corrections. So I don't normally do that, but I know the beginning of the year is kind of a lot to take in. What I want you to know is that while your quiz is 36 points, just next week, your test is 100 points. So it goes from 3 points each to 5 or 6 points each. So you must figure this out by next Thursday, because that test grade will stay. I won't be able to see corrections if you do it in pencil, so you have to use a red pen or highlighter so that I can see them. Okay, or a colored pencil. Alright, and I will be putting out the right answers, so that'll be easy to correct. You have to think about it and figure it out. So you're not off task. It's going to take me a while to pass them out. Don't get off task. Focus. Work on something. Be productive. Every question's worth 3. If it says 1/2, that's like 1.5 out of 3. It's my frying thing. Kira. I'm on Kira. David. Jackson. I'll go over it all. You can figure it out. Once everybody gets their thing, I'll answer questions.
You got one.
I only raised it if it was right.
My God!
I got Ian and David left. Ian. I got David. Yeah, just a moment. One more moment, and Mama's ready. There were a couple of 100s. There's even some people who got the extra credit, so there were some over 100. Is this your thing? You guys have multiple choice? What's your number one? Does your number one look like this? It's multiple choice. Which version are we looking at? All right, here are the right answers. Okay. So we got B and C, or B and E are quadratic because they have the exponents. That's quadratic. A lot of people try to like match the thing instead of looking for the distinguishing feature. So this line, if you had the parent function, that's half credit. Some people just forgot to put the parent function in, so you got your parent function here, and then you should have been up 4. Lots of students were right 4. Oops, fix it, figure it out. This one, you got your positive going up, and then the reflection going down. This is the original, and then on number 3, you should have moved left 4. You didn't get yours. Who else didn't get theirs? What's your last name?